Welcome back to Computer Lessons.
We have spent the last few weeks engineering a marvel of logic and electricity, assembling the brain, the heart, and the nervous system of our machine. But if we leave these delicate components exposed on a desk, they are vulnerable to dust, static shock, and physical damage. To transform this pile of parts into a functional computer, we need a chassis, a skeleton, and a skin that defines its identity. Today, we are talking about the case. To the uninitiated, it looks like a simple metal box designed to hold components together. But to an engineer, the computer case is a wind tunnel, a Faraday cage, and a complex ecosystem that dictates the lifespan of every component inside it. The first decision you make when choosing a case is not about aesthetics, it is about the form factor. Form factors are standardized dimensions that ensure your motherboard fits inside the box. The standard that has ruled the industry for decades is ATX, or Advanced Technology Extended. An ATX mid-tower is the Goldilocks size for most users. It is large enough to house a full-sized motherboard, multiple graphics cards, and plenty of cooling fans, yet small enough to fit under a desk. It offers the perfect balance between expandability and thermal management, providing ample volume for air to circulate. However, computers are shrinking. We have the Micro-ATX form factor, which cuts the height of the board in the case. These cases are shorter and often cheaper, but they sacrifice some expansion slots, forcing you to be more deliberate with your component choices. Then, there is the challenge of Mini-ITX. This is the art of fitting a supercomputer into a shoebox. Building in these cases requires the patience of a surgeon, as you are fighting for every millimeter of clearance. In a Mini-ITX build, airflow is not just a feature, it is a critical survival requirement. Because the components are packed so tightly together, heat pockets can form instantly. Engineers often use sandwich layouts, placing the CPU and GPU back-to-back to give them independent access to fresh air. Once you have chosen your size, you must understand the physics of airflow. The goal is simple. Move cool room air over the hot components and exhaust the heated waste air as quickly as possible. But achieving this requires a strategic understanding of turbulence and pressure. We touched on pressure briefly before, but let's define it strictly in the context of the chassis. Positive pressure is achieved when your intake fans are pushing more air into the case than your exhaust fans are pulling out. This forces air to escape through every unfiltered crack and gap in the chassis. Why is this desirable? Because it prevents dust from being sucked in through those unfiltered gaps. By forcing air out, you ensure that the only air entering the system comes through your designated filtered intake fans, keeping the inside of your PC clean for years. Negative pressure is the opposite. You have more exhaust than intake. This creates a vacuum effect, sucking air and dust in through every open slot, screw hole, and seam. While negative pressure can sometimes offer slightly lower temperatures by removing heat aggressively, the dust buildup will eventually clog your heat sinks and reduce performance. The ideal setup for most people is slightly positive or neutral airflow. This usually means having 3 fans at the front pulling cool air in, and 1 or 2 fans at the rear and top pushing hot air out. This creates a directed wind tunnel, a river of air that flows smoothly from front to back. However, the material of your case can ruin this river. In recent years, we have seen a trend of tempered glass cases. While they look beautiful, glass is a solid wall that is completely impermeable to air. If you mount fans directly behind a sheet of glass with only tiny vents on the sides, you are choking your system. The fans struggle to pull air through those small gaps, creating noise and failing to cool the components. For high-performance systems, mesh is the king of materials. A mesh front panel allows air to pass through with almost zero resistance. It turns the entire front of your computer into a breathable surface. If you are running high wattage parts like an RTX 4090 or a top-tier CPU, a mesh case is almost mandatory to prevent thermal throttling. We must also talk about the internal obstacles. In the early 2000s, computer cases were filled with massive drive cages for CD-ROMs and hard drives right behind the front intake fans. This blocked the air immediately, preventing it from reaching the motherboard. Modern case design utilizes the open layout concept. Drive cages have been moved to the basement or behind the motherboard tray. This leaves a completely unobstructed path for the air to travel from the intake fans directly to the GPU and CPU coolers. This brings us to the PSU shroud, or the basement. Most modern cases have a metal cover at the bottom. This isn't just for hiding ugly cables. It separates the power supply and its heat from the rest of the system, creating a dual-chamber thermal design. Speaking of cables, cable management is not just for obsessive-compulsive aesthetics. A rat's nest of cables hanging in the middle of your case acts as a physical barrier to airflow. It creates turbulence, breaking up the smooth stream of cool air and causing it to swirl around without cooling anything. By routing cables behind the motherboard tray and tying them down, you are aerodynamically optimizing your machine. You are reducing drag. It is the same principle used in automotive design applied to your desktop computer. Let's discuss the fans themselves, as the case dictates what fits. Larger fans are generally superior to smaller fans. A 140mm fan can move the same amount of air as a 120mm fan, but it can do so while spinning slower. Slower spinning means less noise and a lower pitch sound profile. A good case supports these larger fans, allowing you to have a system that is whisper quiet, even under load. Smaller cases often force you to use small, high-pitched fans that sound like a swarm of angry bees. Another modern innovation is the vertical GPU mount. This allows you to show off the face of your graphics card through the glass side panel. But be warned, if you mount an air-cooled card too close to the glass, you are suffocating it. The fans on the graphics card need room to breathe. If they are pressed against the glass, they cannot pull air in, and your beautiful aesthetics will result in a loud, overheating system. Always check the clearance before choosing a vertical mount. We should also consider the sleeper build philosophy. Some enthusiasts take an old beige yellowed case from the 1990s and modify it to hold modern supercomputer hardware. While hilarious and unassuming, these old cases often lack the ventilation needed for modern 500-watt GPUs. This requires heavy modification, cutting holes for new fans, and engineering custom air ducts. It highlights how much case design has evolved from the era of low-power floppy disks to the era of high-performance rendering. The box has changed because the heat has changed. Sound dampening is another battleground. Some cases come lined with heavy foam to absorb noise. While this makes the PC quiet at idle, it insulates the case like a winter coat, trapping heat and forcing fans to spin faster, which ironically creates more noise. Ultimately, the case is the home you build for your digital family. It determines how easy it is to upgrade, how cool your parts run, and how often you have to clean out dust. It is the marriage of industrial design and thermal engineering. We have now built the entire tower. We have the processing power, the memory, the storage, the power, and the cooling, all housed in a chassis. But a computer is useless if it cannot communicate the results of its calculations to you. We need a window into the digital soul. We need to see the pixels we have been talking about. We need to understand the physics of light. In the next video, we are going to look at monitors and display technology. We will decode the difference between LCD, OLED, and the importance of refresh rates.
I want to know your preference. Do you prefer a case that looks like a glass aquarium with RGB lights, or do you prefer a stealthy black box that disappears into the room? Let me know in the comments below. If you found this explanation helpful, please hit the like button and subscribe to Computer Lessons. Don't forget to click the bell icon so you don't miss our next class. Thanks for watching and keep learning.